Hi, we're working on Al Grosch's book, Developmental Math 2. We're in section 5.9, multiplying and dividing rational expressions. Okay, we're going to first talk about simplifying rational expressions. And a rational expression is just a fancy word for a fraction. So we're going to simplify a simple fraction, 10 over 35. And I'm just going to kind of direct you to look here. If you factor the numerator, it becomes 2 times 5. The denominator becomes 7 times 5. And then you can cancel factors that match, and you end up with a simplified fraction of 2 over 7. You can do the same thing over here with an algebraic fraction that has variables. X to the 5th power is 5 x's multiplied together. X to the 3rd power is 3 x's multiplied together. And when you cancel the factors that match, you can see 3 x's in the numerator and the denominator being canceled because the same number in the numerator and the denominator reduces with the same number. So just like this. So you're left with x squared, or 2 x's multiplied together here. When we look down here at a more complex rational expression, we have a trinomial x cubed minus 8x squared minus 2x being divided by x squared minus x. And again, we can factor the numerator by factoring out a GCF of x. We're left with x squared minus 8x minus 2. And if you don't know how to factor, you need to go back and review some of the factoring videos. This is not a factoring video. This is just telling you that you need to factor. So go back and review factoring if you don't understand factoring. In the denominator, we can factor out a GCF of x, leaving us with x times x minus 1. And then we can cancel those x's as a common factor. Okay, you can see that being canceled there. Actually, you can't see it, so let's do it. Maybe. There we go. Those factors will be canceled. And we're just left with, in the numerator then, x squared minus 8x minus 2, and in the denominator, x minus 1. There's a mistake over here in the printing. You can't see the x that's being canceled, but over here you see the correct result. The same idea is going to happen over here. You have a trinomial in the numerator that factors to make 3x plus 1 times x minus 3. And if you review the factoring videos, I believe it's factoring, the second part of factoring trinomials, you will see how to factor this. This is the difference of squares in the denominator, so this factors here, and then these x minus 3's can cancel. So one thing we probably need to talk about is that this x here cannot cancel with this x because these are not factors. These are terms. Anything that's being added and subtracted cannot cancel. These are factors, these binomials, because the operation here is multiply. These can be canceled. So most of the time, pieces of your binomials are not going to cancel individually, like this 3 can't cancel with this 3 because these are terms. They're being added to something. They cannot cancel. Only entire binomials. Back over here, these x's were factors because the operation here is multiply. So these can cancel, but this x can't cancel with this one because these are terms. The operation is add or subtract here. So we're left here with 3x minus 1 from here over x plus 3. All right, let's go to the next page. All right, so this is the next page, and we're gonna add on some multiplication. We're gonna multiply two simple fractions, and we're going to use the factoring to help us multiply. We could, if you remember rules for multiplying, we could multiply 5 times 21 and make a new numerator, 14 times 10 and make a new denominator, but those are going to be pretty big numbers, and then we will have to reduce or simplify them. If we use factors even for simple fractions, it makes the reducing easier and also the multiplication because it keeps our numbers smaller. So I'm first going to factor 5 over 14. 5 is already prime, so it isn't going to factor. The 14 factors to be 2 times 7. And we're going to factor 21, which is 3 times 7. I have a little bit of trouble with my pen here. And we're going to factor 10, which is 2 times 5. And now we're going to do what we call cross-canceling, where a numerator factor can cancel with the denominator diagonally, or they can also cancel vertically. So we see these two 5s here. They can cancel. We also see the 7s here that can cancel. I do notice that there's two 2s, but these can't cancel. You can't cancel two denominators, you can't cancel horizontally like this. You can cancel vertically or diagonally, but you cannot cancel horizontally, either this or this. So this is what we're left with here. We have a 3 in the numerator and a 2 times a 2 in the denominator, which would be 4. So all of this multiplies together and reduces to make 3/4. A lot of students find this to be a lot easier than multiplying bigger numbers and then trying to find the common factors to reduce. We're going to do the same thing over here with the algebraic fractions. So first, x to the 5th is 5x's over, this is a y squared. I know it looks a little odd, the printing is not quite right, but this is supposed to be a y squared. So that would be 2y's. There's a y in the numerator, and then 3x's. So all of those come from this second fraction. All of these come from the first fraction. Now we can cancel diagonally. There's 3x's here, so we can cancel them with 3x's here. This y can cancel off one of these y's. And so we're left with 2x's multiplied together in the numerator, or x squared, and looks like just the one y factor in the denominator. So x squared over y. I'm going to scroll down here just a little bit so that we can look at these down here. All right, so we have some more complicated rational expressions here involving some addition, subtraction, and this is where you have to think about your polynomial factoring. And again, like I said on the last page, if you don't know how to factor, you're not going to be able to reduce these. You need to go back and watch some factoring videos. So we're going to factor. It looks like here there's a GCF of x squared. So I'm going to factor out an x squared, and I have x minus 2 left. In the denominator, there's a GCF of 5. So I'm going to factor out a 5, and that leaves me with x plus 1. And this side, there's nothing to factor in the numerator. 5 is already prime. But the denominator here has a GCF of 3. So we're going to factor out a 3, and we'll be left with x minus 2. Now we can look, remember, diagonally or vertically. We can cancel. And it looks right off the bat like that we can cancel these 5's. And we can also cancel x minus 2. This x squared cannot cancel with this x, because remember, this is being added, so this is a term. Can't cancel this pieces of a binomial. You can only cancel the binomial with another identical binomial. So it looks like we have an x squared left in the numerator, and a 3 times an x plus 1 in the denominator. You can see down here that your author, this is their final answer right here, which is the same as ours. This one. Your author went ahead and multiplied out this denominator using distributive property. Most teachers don't really care if you do this. In fact, myself like it better in factored form like this. If you have to go another step or you have to do something else with it, you're going to need it in factored form anyway. So it's really not necessary to go ahead and multiply it out. If you're in my class, I prefer it in factored form. All right, let's look over here. We got some really complicated factoring going on here. So trinomials, two trinomials in the numerator, a couple binomials in the denominator, and the factors are all down here if you want to look at them. I'm going to rewrite them over here. So factoring x squared plus 5x plus 6, we're going to have x plus 2 times x plus 3. In the denominator here, this is the difference of squares. So we're going to have x plus 4 times x minus 4 multiplied times, over here, 2x squared plus 9x plus 4. And here's the factors right here. I'm just going to rewrite them for us. That factors into 2x plus 1 times x plus 4. The denominator, x squared plus 2x, has just a GCF of x. So we're just going to factor out an x. And we're left with x plus 2. All right, and then, like I said, we're going to look for any common factors either vertically or diagonally. It looks like we've got an x plus 4 here that we can cancel. Oh, not that one, this one, x plus 4. And x plus 2 here can cancel. And that's about it. This x right here is a factor, but it cannot cancel with either one of these because these x's are both tied up in binomials. This one's a term, and this one's a term, so these ones can't cancel with this x. If there was another x as a GCF out here, we could cancel this one, but right now these cannot cancel because these x's are parts of binomials, they're terms. So it looks like we're left with these two binomials in the numerator and x times x minus 4 in the denominator. So x plus 3 times 2x plus 1 over x times x minus 4. And that looks like our final answer there. So let's go to the next page. Wait, before we go to the next page, let me just mention this again. It looks like the author went ahead and multiplied this out. You do not need to do this unless your teacher specifically asked for it. This factored answer, which is the same as ours, is a perfectly acceptable answer, and in my class, I prefer the factored answer. So this is perfectly fine. All right, let's go to the next page. All right, we're going to do some division now, which is very similar to multiplication. All right, dividing some simple fractions first. Remember the rule for dividing fractions. A lot of students like to use an acronym called KCF. Stands for keep, change, flip. So you keep the first fraction, you change to multiply, you flip the second fraction. So that's the important part. You have to remember to flip the second fraction. So we're going to use factors again. I'm going to factor each of these numbers. As I'm factoring, I'm going to change this to multiply, and I'm going to flip the factors of this fraction. So first, 2 over 15. 2 is prime, so we just have that in the numerator. 15 is 3 times 5. I'm going to change to multiply, and then I'm going to put the factors of 6 down here on the bottom, and that would be your flip. So 6 factors to be 2 times 3. 35 factors to be 5 times 7. And now again, you can cancel vertically or diagonally. So it looks like we've got some 2's here that will factor, and these cancel, these 5's. So what are we left with in the numerator? Looks like we're left with a 7. In the denominator, 3 times 3. So that would be 7 over 3 times 3 is 9. If you look down here, you can see all of that right there is what we just did up here. So we're going to do it over here with algebraic fractions. I'm just going to split now. These are monomials, so your factoring is easy. You just have to tear them apart. You don't have to worry about that polynomial factoring that I referred you to the other videos for. If you're factoring with monomials, you just tear them all apart, and you can kind of see it down here. We're going to write it up here. So we have x squared, x times x, over y cubed, which is 3y's, and a z. We're going to change to multiply because don't forget, your rule is keep it, change it, flip it. So this one is going to get flipped. Over here, the numerator just has an x, so it's really not even being multiplied times anything. So that x is going to go down here. And then the 5y's up here, and a z. And now we need to reduce or cancel. We can cancel these x's. There's 3y's here that can cancel with these 3y's, and this z can cancel with this z. So that looks like it just leaves us with an x and 2y's in the numerator, which would be x, y squared. Now notice, I have no denominator here, because when everything cancels off the denominator, that just makes a 1 in the denominator, and it's okay to just lose it. You can't lose your numerator. If everything has gone out of your numerator, you need a 1 in the numerator, but you can lose the denominator anytime you want. This just is saying this is a whole number, no longer a fraction. All right, let's scroll down, see what we have down here. Some more complicated rational expressions. So we're going to need to factor. Excuse me. Let's see. All right, x squared plus 3x has a GCF of x. So we're going to factor out an x, and we'll have x plus 3 left. I'm actually wondering if it would be better to write this down here. Let's try it here. The denominator of this fraction right here is a monomial. So you just need to tear it apart to its prime factors. So 5 and y times y would be 2y's. Change this to multiply, and don't forget, when you have division, you flip this second fraction. You change to multiply, you flip the second fraction. So the 2x for the numerator goes down to the denominator, and again, it's just a 2 times an x, and actually you can write the multiplication between them so that you know they're not stuck together. This denominator has a GCF of y, so we're going to factor out a y, and that leaves us with y plus 2. And now we can look for anything that cancels. And the reason here why you probably should tear these apart is because it looks like this x can cancel with this x, but the 2 is not. They're not stuck together. They're different factors. So we can cancel this x with this one. We can cancel one of these y's with this one. These 2's, remember, don't cancel because this one is a factor, but this one is a term because it's being added to something. So this can't cancel. You cannot cancel terms, only factors. So it looks like we have x plus 3 times y plus 2 in the numerator. If only I had a good place to write this. X plus 3 times y plus 2 in the numerator over, we have a 5 and a y, 5 times y times 2. 5 times y times 2 is 10y in the denominator. And that's our final answer. You could see it right here. So all of this is here, all the factoring and everything, and then the final answer is down here. And once again, I'm going to say this. Your author multiplied these out, the x plus 3 times the y plus 2, and got this. I prefer a factored answer. So if you're in my class, leave your answers in factored form. If your teacher prefers a multiplied out answer, you need to discuss that with them. All right, let's look over here, see what we got. We got a couple trinomials in the top, division, which we're going to change to multiply and flip the second fraction. So let's make a notation of that before we forget about it. Flip the second fraction. All right, let's factor. X plus 3, x squared plus 3x plus 2. Factors to be x plus 2 times x plus 1 over x squared minus 3x has a GCF of x, so x times x minus 3. We're going to change this to multiply, and we're going to flip this second fraction. So I'm actually going to do the denominator first. This is the difference of squares, but I'm going to write them in the numerator. So those factors are x plus 3 times x minus 3 over the factors of 2x squared plus 5x plus 2 are going to go down here. They're right there. You really should pause this video right here and factor it yourself, because that's the only way you're going to learn. 2x plus 1 times x plus 2 that's x plus 2. I'm having some trouble here, I'm sorry. And we can cancel x minus 3, x plus 2. It doesn't look like anything else is going to cancel. And I want you to be careful. This x cannot cancel with this one because this one's a term. Same thing with this one here. These x's cannot cancel. They're both terms. When you have binomials, you can only cancel them with other binomials that match. So it looks like we have x plus 1 times x plus 3 over x times 2x plus 1. And that's what it looks like we have here. You can see it right there. Okay, let's go to the next page. All right, looks like we have some practice examples that don't show us the steps, so we're going to have to work these out on our own. First, we're going to multiply some simple fractions here. So again, we're going to factor so that we can cancel. Having a little trouble with my pen here. Okay, let's factor. The factors of 3 are just 3. The factors of 28, and if you don't remember, you can use the factor tree on 28. 28 is 4 times 7, and 4 factors down to be 2 times 2. So there's your prime factors, 2 times 2 times 7. And we're going to multiply that. In the numerator, 14 is 2 times 7. In the denominator, 15 is 3 times 5. And we're going to cancel the factors that match. These 3's, a 2, and a 7. That leaves us with, across this numerator, everything is canceled, but you cannot lose a numerator, so this is going to all come reduce out to be a 1. So we have a 1 in the numerator. The denominator has a 2 times a 5, and of course that makes 10. So this becomes 1 over 10. I'm going to do the same thing over here with the variables. These are just monomials. So we're just going to tear that multiplication, all apart, starting with x to the fifth, 1, 2, 4, 5, over y cubed. After you do this and you get some experience with this, you probably won't have to write all this out like this, but it's okay to start with writing things out. In the numerator over here, y times e to the 4, so that'd be 1y and 4 z's over x squared is 2x's. And now we're going to cancel. This y can cancel off one of these, and this z can cancel one of those. And both of these x's will cancel 2 of these. So we're left with 3x's, which is x cubed, over times 3z's, which is z cubed, over y times y, which is y squared. All right, now we have some more complicated multiplication, which involves factoring, polynomial factoring. So we're going to factor. Looks like there's a GCF here of 2x squared. So let's factor out 2x squared. We're left with x squared minus 3. In the denominator, a GCF of 7 times x plus 2 times 7 is prime. So there's no factoring going on, and the denominator here is a monomial, so again, just pulling it apart, 2 times x. That brings me to another thought here where you might want to just pull this apart. I'm going to x that off, and I'm going to write it as 2 times x times x. That would be 2x squared, because I see this 2 canceling with this 2, and this x canceling with this x, but this one is still there. The 7's also cancel. So what are we left with up here? We've got an x here and an x squared minus 3. So that would be the numerator. X times x squared minus 3. And the denominator, it looks like just this x plus 2 is left. And again, I'm going to draw your attention to this x cannot cancel with this one because this one is being added to something. It's a term, not a factor. These do not cancel. These will not cancel. So this is your final answer here. If your teacher likes for you to multiply this out, that's perfectly fine. But this factored form is generally an acceptable answer. Let's go over here and start factoring. In this numerator, there is a GCF of x squared. And we have left 3x squared plus 5. And again, I really think that I'm going to tear this x squared apart and make it x times x. In the denominator, we have 6x squared plus 13x plus 6, which factors to be 2x plus 3 times 3x plus 2. If you don't know how to get those factors, you need to stop this video right now. Go back. I have factoring videos here on my YouTube channel. I have probably 10 or 12 of them. Go backwards and review factoring trinomials. This numerator 4x squared minus 9 is the difference of squares. So those factors would be 2x plus 3, 2x minus 3, and the denominator is just a monomial, x cubed, we just tear them apart, and that's why I did this, because you can see these two will cancel with 2 of those. So let's do that. Those 2 cancel 2 of those. Is anything else going to cancel? Let's see. Oh, we have a 2x plus 3 here. We can cancel those. It doesn't look like anything else cancels. Now be careful. These are not going to cancel. 3x squared and 3x because they're terms. You can only cancel a whole binomial with another identical binomial. So it looks like what we have here is 3x squared plus 5 times 2x minus 3 in the numerator over 3x plus 2 in the denominator. All right, I think we have one more page. All right, we're going to work on some divide here. All right, don't forget that dividing with fractions is keep it, change it, flip it. So you always flip this second fraction. We're going to first divide these up into factors. So the factors of 6 are 2 times 3. The factors of 25, 5 times 5. Change to multiply. The factors of 18, 2 times 3 times 3, or 2 times 9 makes 18, or 6 times 3 makes 18. Either way. And I forgot to flip it. So let's see. I can't erase. Okay, so it looks like I got it off there. So we need to put the factors for 18 down on the bottom. 2 times 3 times 3. And 35 is 5 times 7. And we're going to cancel the factors that match, either diagonally or vertically. So we can cancel those 5s. We can cancel a 2 with this 2 and this 3 with this 3. So it looks like we have a 7 left in the numerator and 5 times 3, or 15, in the denominator. Okay, over here, don't forget, keep it, change it, flip it. So we're going to flip this second fraction. So 5 times x is a monomial. I'm just going to tear it apart. 5 times x, y cubed, y times y times y. Change to multiply. 15x, I'm going to tear the 15 apart to be 3 times 5 times the x. And this time I'm going to remember to put it on the bottom. 3 times 5 times x. And then this y squared z will go up here. Y squared is 2y's and a z. Now we can cancel. I can cancel this 5 with this 5, this x with this x, 2 of these y's with 2 of these y's. So it looks like we have left in the numerator a z over, here's a y and a 3, so that would be 3y. All right, and these are more complicated factoring down here. So we're going to start with 3y squared, which is a monomial. I'm just going to tear it apart. I'm actually going to put those arrows on so I don't forget to flip. So 3y squared is 3 times y times y. 5y squared plus y, it has a GCF of y. So we'll factor out a y. It'll be 5y plus 1. That's going to be times y squared plus 2y has a GCF of y. I'm going to remember to put it on the bottom, times y plus 2. And the denominator, 5y plus 1, doesn't have any GCF. There's nothing common. It's not a monomial, so it's prime. There is no factors here. So I'm going to use some parentheses, though, to remember that it's a binomial. It can only cancel with another binomial. Now, what do we have going on here? These y's are factors. This y is a factor, and so is this one. So if you remember, I told you could cancel either vertically or diagonally, and it looks like these two y's are each going to cancel with these, because these can cancel vertically and these can cancel diagonally. So let's cancel those y's off. It also looks like 5y plus 1 is going to cancel diagonally like this. So we're left with in the numerator a 3, and in the denominator, just y plus 2 from here. All right, let's go over here to this one. Got a lot of factoring going on here. And I'm going to remember to make my little arrows so I don't forget to flip that one. Okay, this numerator, x squared minus x minus 42, will factor to x minus 7, x plus 6, and again, if you don't know how to do that, go back and review the factoring videos. 2x squared minus 13x minus 7 will factor to be 2x plus 1 times x minus 7, changing to multiply. The denominator here, x squared minus 49, is the difference of squares. So we're going to write that as x plus 7, x minus 7 in the numerator, because I remembered to flip. The top, the numerator here, has a GCF of x, so we're going to write that down here. So x times x plus 6. Now, we only have this one monomial here, and there's no lone x's to cancel with it, so we're going to have that one left standing alone. So let's look and see. This x minus 7 can cancel with this one, but this one can also cancel with this one, but only one or the other. You can't cancel both. You can cancel these vertically, or you can cancel these diagonally, but not both. So let's just do diagonal canceling. That's what we do most often. This x plus 6 can cancel with this x plus 6, and it looks like that's going to be it. So in the numerator, we have left x minus 7 times x plus 7 from here and here, and in the denominator, an x here times 2x plus 1 from here. Looks like that's about it.